Hi everybody, this is Amir. I was watching GIS Chops. He has a YouTube video channel, and he enters subdivisions on his free time on Fridays. And one of the things that were challenging was connecting these lot lines. So after the lines have been broken on the roads or the subdivision exterior, you basically want to connect the dots, but you only use the original COGO measurements. So GIS Chops was using the traverse tools, setting the start point, end point, entering the COGO measurements one by one. And the reason he could not use the direction distance tool, which is here, right, started in 2-point line, right click direction distance, or the G key 0.1, is because it always came to an undershoot or an overshoot. The size here is precisely 10 by 10, so if I go anywhere near 10, it would create an undershoot or an overshoot, right? And wouldn't close, which will then you need to use extend and trim and so on. So that's not very handy. So I created this attribute rule that will do it for us. So as I press enter, if it's within 1 meter, that's the tolerance I set, it will automatically extend it to the precise measurement. Let's do one more. I'll press the G key now, and I'll specify the direction, and let's specify 10.5 this time, so it will be an overshoot, and you'll see that it came back to where it's supposed to go. You also can see that the entered COGO measurements are preserved, so 950 and 1050 exactly as entered. And would this work if I also digitize? And I can set here a grid of, and you can see that if as long as I come into 1 meter anywhere from the point, it will automatically snap to the correct location. Let's turn this off. Other things you might ask yourself, what happens if I start a point, but I'm within 1 meter? Let's press the grid again here so we can see it. But there's no vertex around me. Well, then it will not do anything. Another thing you might ask yourself, what if I were to enter a curve? So let's use this mode. I'll start point, end point within the tolerance, and then I'll give it the values. So again, if it's a curve, it wouldn't work. So how is this implemented? It's implemented using an attribute rule. We can view the attribute rule by going to Data Design, Attribute Rule, and I'll explain a bit on this rule, and if you want to set it, how you can set it up. It's a calculation rule that basically updates the geometry of the feature you are entering. So it works on the shape fields, and it only does it when you create a new feature. So not for updates or deletes, only for inserts. If we now look at the logic, I'll explain a bit for those that want to understand. So here you can set the tolerance. So 1 meter is obviously too big. It's for this demo. You might want to choose something smaller, like maybe 0.1. You can set your units here, meter, feet, US feet, whatever makes sense. Then we create a feature set by name. So this is where you'll have to set the name of the table. In my case, it's the parcel underscore lines table. You might have another name for your feature class. And if you're using an enterprise geodatabase, of course, it will have the fully qualified name, which is that name that specifies also the owner name, dot something. So make sure you have the full table name listed here. So once you set those 3 things, you should be good. If you want to continue seeing this video, I'll just explain what's going on here so you can understand. The first thing we do is find the vertex of the end of the 2-point line feature that we are working on. So this command, the geometry of the feature we are creating, and the path 0, 1 is basically the end vertex. And so that allows us to extract the end x and end y coordinates of this feature. Now we are going to buffer that end vertex geometry using the tolerance. So if I use 1 meter, it will basically, you can imagine a circle of 1 meter around the end vertex of the feature we just created. And that buffer is used next to find the first line that intersects with that buffer. So it's basically looking for any lines in that radius, and if it finds one, the first one, it will find the nearest vertex of that line. So using the nearest vertex method. So this gives us basically the vertex that we want to snap to. Unless, of course, the nearest vertex might be more than 1 meter away, it might be 10 meters away. So we'll have a check soon to make sure that it's not too far away. So the next thing we ask is the new feature we just created a 2-point line? And this basically does that. We have to make sure that the number of paths in the geometry is exactly 2. The other thing we have to check is that the vertex we have found is not null. It's not empty. If we haven't found any vertex, there's nothing to do. We can basically move on. But if there is a vertex found and it's a 2-point line or a curve, then we can start creating the geometry. So the first point, we're basically updating the geometry of the feature. So we want the first vertex, which is this command, x and y coordinates of the first vertex. And then we have the target new geometry, which is the coordinate of the vertex we found. So we're going to stretch the new line from where it used to start to this new end location. And then we also have to make sure that the vertex that it found is not by mistake. If the point is less than the tolerance, like if the line is distance is less than the tolerance, if you create a half a meter, let's say, line, and the tolerance is 1 meter, it might find the vertex where it started from because there's another line there. So we want to make sure this is not the case. So here we safeguard that we don't close the line on itself, basically create a 0 length line. So if that is the case, we basically x1 is equal to x2 and y1 is equal to y2, we return. The next safety check is that the vertex that we found is not too far away, not bigger distance than the tolerance we specified from the end vertex. So we calculate the distance, and if the distance is bigger than the tolerance, we also quit. But if all those safety checks passed, the only thing that is left, let me correct the spelling mistake, is to basically extract the spatial reference of the geometry and create a new polyline that starts from x1 to y1 to x2. y2 uses the spatial reference of the spatial reference we just extracted here. And then we update the shape field by returning the new polyline using this polyline JSON format. So you can always validate your expression to make it valid, apply it. I'll discard my edits to remove the schema lock, save the expression. Now it's with 0.1 tolerance, and you should be good to go. This is kind of an experiment. It's in beta. I find it not very convenient that I cannot disable this rule. So maybe with intolerant it wouldn't cause inconvenience here. I don't know, but if I want to, let's say, create the line to this point, and I'm within 0.1. Well, actually, I was not. Let me try again. So any line you create that is too close to another line will always now snap to within tolerance. So make sure. See, so if it's within tolerance, it will always closed. There's no way to turn it easily on and off. To turn it on and off, you'll have to go and reconfigure the attribute rules again. Basically discard your edits or save them, then go data design, attribute rule, and here you can, on the bottom, you can basically disable the rule easily, save it to the schema, and then do your edit again. So it's not very convenient to do that on and off. So let me know in the comments if you find this useful or not, and we can of course enhance it if you find some need to tweak it. That's all for today. Thank you very much and enjoy your post editing.